Yes.
please. Okay. And Turja, just ask Mustafa to join, okay?
Okay, sir.
Yeah. Ask Mustafa that we're already. And where is the new student? From Halton. I forgot his name. Anyways. Okay. Okay, so let me start the class. Very strange thing. I'm using one computer for my voice and I'm using another computer to show the screen. Okay. If you face any difficulties, please do let me know. Okay, first of all, today I will discuss about, you have to understand that this is very, I will go very quickly. This class is all about introducing the tools. Okay, all about the introducing the tools, meaning that I will just introduce the tools. Don't hope that you will learn everything by through attending 1 year, 1 hour or 2 hour courses. Okay, people have been spending months after months to understand, to realize all of these things. Okay, so only um, 1 hour is not sufficient to understand all of these things. But the purpose of this course is that I will introduce you the tool very shortly. Then if you do more practice using these tools, I believe that you can apply this tool to solve your problem. Another thing is that there are lots of content available online with regard to the things that I will discuss today. So I will give you some knowledge today so that if you go to the internet, if you find any content about the deep learning or convolutional neural network learning, you will be able to at least understand those topics, those uh, events, and you can use these events to solve your problems. Okay, so
Yes, sir.
this
Sir, will you give us permission to record the class?
yes, where is Kamal?
Um,
Shanta?
sir, yet not come.
Shanta?
জি স্যার
Shanta, Kamal কিছু কল দিবা?
জি স্যার শুনতে পাচ্ছেন হ্যাঁ হ্যাঁ জি স্যার জি স্যার
আর তোমাদের ওখানে তো অনেকে মনে হয় জানে না, একটু ভুল হয়েছিল, দেখো তো কারা কারা জয়েন করছি।
জি স্যার 4-5 জন করেছে স্যার, আমি একটু ফোন দিতেছি ওদেরকে বা গ্রুপে জানাচ্ছি।
Okay, okay, okay. So once again, I am telling you that last class we did discuss about some of the machine learning, how we can use the machine learning techniques using Weka or using Python code. Today, I'll discuss about how we can apply a deep learning method. What are the challenges to apply the deep learning method that we face in our life? This is, I mean, the deep learning method is very popular technique these days, but this is not the end of the world. There are many things that we could not solve yet, and how we can solve it. I will just tell you the challenges. And if you are interested, you can conduct some research in this area, or you can apply this tool to solve. If your background is not computer science, you can apply this tool to solve your domain problem. Okay. So convolutional neural network is very popular technique. I mean that in this world, especially image process in the image processing or image analysis or image classification. I do believe that by now you know what is called classification. Okay, if you don't understand what is classification, please do contact me, or I was supposed to form a WhatsApp group, but I apologize that I could not do it last week. I was very busy. I hope that this week I will form the group, WhatsApp group, so that you can communicate to each other. You can communicate with me if any problem you face in the long run. This group will be there, and you can communicate with me at any time. Okay, if you face any difficulties. And sometimes I will knock some of you. If I notice that some of you are doing very good job, I will knock you, some of you, to contribute to some of my ongoing research, and you can be part of my research team. Okay, so what is a convolution? Convolution is a traditional image processing technique. It is a very old technique that people used to analyze the image. In fact, the convolution is used to detect edges from the images automatically. I will today, first part of the lecture will be how does convolution works on an image, and the second part is that how this idea can be used to automate a computer. Okay, so first let me show you what is a convolution. Convolution is a mathematical techniques. In fact, convolution, whenever we say convolution, convolution is a mathematical matrix. Let me give you I'm jumping into the, without telling anything about the behind theory, I'm jumping into the practical things. So let us consider that we have got a 6x6 images. Okay, we have got the 6x6 images. What does it mean, 6x6 images? Those who are not familiar with the image, let me tell you the things. Image is in the computer, image is stored as a matrix. Image is stored as a matrix. So what is a matrix? It is a two-dimensional, it looks like a two-dimensional table. So if we consider this is the x dimension, or we can say this is the column, and we can call this is a y dimension, or sometimes we call it as a row. So it is a column and it's a row. You can see there are 6 columns and there are 6 rows. So using these data, we can easily create an image. I will show you in practice how an image is stored into the computer and how we can extract some information out of the image in today's class. Then I will go for the deep learning. So let us consider that we have got an image and the size of the image is 6x6, meaning it has got 6 column and 6 row. Each of the column or each of the cell in this matrix, we call it, this is a cell, this is a cell. Each of the cell can have some integer value. So what is referred to the integer value? Integer value meaning the value could be any complete number like 100, 200, 550, okay, 15, 9. This is a complete value without any value after the value, I mean only without any decimal point after the value. That is called the integer value. So if the values in an image are always an integer value. For example, here 1. So it is we can easily say this is a black and white image. 1 represent white color and 0 represent black color. Okay, so this is a black and white image and it has got the 6x6 image. So ideally, I mean that this image will look like this. There will be a straight line. If I draw the image, there will be a straight line. There is another straight line, and this line is black color, and the background will be white color. This is a straight line, and this is straight line. So the image will look like this. Okay, now the question comes in is that if we have got an image, okay, if we have got an image, how we can detect the edges from the image? Let me give you another example. Let us consider that we have got an image of a bird, okay. Now I'm interested to learn the edges of this bird. So if I draw the edges of the bird, this will be the edges of the bird. If I draw, okay, this is the edges of the bird, and this has got many application. If we want to detect the edges, it has got many application in the real world. Okay, in the GIS, in the biology, in the forestry, in the agriculture, you can apply this technique to detect some images, edges from your domain images. So if I look at the try to find the edges of this bird, so this red color line will show the edges of this bird. Everybody,
Yeah.
if you have got
Yes,
any
sir.
question, feel free to ask me question. Okay,
All right.
now I mean that let us go to the slide that I was showing you, this one. Okay, so now what will happen in this image, in this black and white image, if I look at the image, it will be like this. This will be one line, this will be another line, and of course it will be black color line. This will be another line, and this will be another line. Okay, now I want to identify the edges in this image. So of course, if you look at this edge, this will be one edge, this will be another edge, and this will be another edge. and this will be another edge. So I want to extract these edges from this image. You know, in traditional techniques, they use a filter. They use a filter to identify the images. It is a very old technique. It is a 50 years old technique. You know, mathematician usually used this sort of metrics to identify the edges from this image. Now the matrix, we call it a filter. So or sometimes we call it kernel. Sometimes we call it they're the same. Sometimes we call it kernel, sometimes we call it filter, or sometimes we call it a convolution matrix. Convolution matrix. Okay. And sometimes we call it a two-dimensional convolution. Why? Because it has got two dimensions. This is one dimension, this is another dimension. That is a one-dimensional convolution that is used in a signal processing. Signal processing meaning, let us consider that I'm talking something and my speech can be represented like this wave. Then I want to identify how does this speech matches with your things to identify the speaker recognition or something like this. So that is another issue. There are different types of convolution matrices available, but in the image processing, the basic is that we use the two-dimensional convolution matrix, or sometimes we call it kernel, sometimes we call it filter. Now, how do we decide the filter to identify the edge from an image? Of course, one condition is that the size of the filter will be, anybody is recording? Is there anybody who is recording my this class?
No, sir, need permission.
So who wants to record it? Please let me know. Kamal, are you there? Kamal, I'm giving permission to you. Please, you can record it. Okay.
But just I am starting.
Okay, let me check how I can give you permission. Kamal. Allow to local files. Now you can start recording. Come on, please.
Okay.
Recording in progress.
Okay. So now, what I was trying to say is that what is the condition of this filter? The filter size will be always less than the